Let's talk about squares, which are probably the coolest four-sided figures because we know so much about them. Squares are parallelograms, and they're rectangles, and they're rhombuses. Squares are kind of a combination of everything that we've learned so far. By definition, a square is a parallelogram with four congruent sides, that's what makes it a rhombus, and four congruent angles, that's what makes it a rectangle. So since we're told it's a parallelogram and a rhombus and a rectangle, everything that we've learned so far has to be true about a square. So this is all the stuff we would know because it's a parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other, and we would know that the opposite angles bisect each diagonal, the diagonals are perpendicular, and the diagonals are congruent to each other. So much information. So let's put that knowledge to use and figure out the answers to each of these questions. Which side is JK congruent to? All the other three. Because it's a square, that means it's a rhombus, which means all four sides are congruent. So you could either say for your justification that this is definition of square, or you could also say that it's the definition of rhombus. What about JN? Which segment is JN congruent to? Well, JN is one of the parts of one of the diagonals, and we know by the diagonals of a parallelogram theorem that the diagonals cut each other in half, so I at least know that JN is congruent to NL, but it would also be congruent to KN and MN because of the diagonals of a rectangle theorem. So since this is a parallelogram, squares are always parallelograms, the diagonals cut each other in half. But since it's a rectangle, we would also know that the diagonals themselves are congruent. So if you cut two things that are congruent in half, then each of the halves would be the same. So actually all four of these diagonal segments would have to be congruent to each other. And that kind of leads us to JL being congruent to MK because of the diagonals of a rectangle theorem. MJK would be congruent to all four of the other angles. MJK is one of the four angles of the square, and since it's a square, or since it's a rectangle, all four angles have to be the same. Angle JNK is one of the four angles created by the intersection of the diagonals, and since a square is a rhombus, we know that all four of these angles must be right angles. So I can say that angle JNK is congruent to KNL, is congruent to LNM, is congruent to MNJ, because of the perpendicular diagonals of a rhombus theorem. And I'm going to erase what we have so far so we can look at this last question. MJN is congruent to, well, here's MJN. It's one of the angles created by the intersection of the diagonal with an angle of the square. And since a square is a rhombus, we know that the diagonals cut each angle in half. So I would at least know that MJN is congruent to KJN. But since the opposite angles are congruent, we would also know that it's congruent to KLN and MLN. But since we also know that all four angles are congruent, and the diagonals bisect each pair of opposite angles, well, if this angle was congruent to the other three, and it was cut in half, then cutting it in half for each of these angles, all of those angles would have to be the same. So I know it's kind of ridiculous, but all of these angles are all the same. These two, and these two, and these two, and these two, all 8 of those angles are all the same by a combination of the bisected angles of a rhombus theorem and the definition of rectangle. Like I said, we know so much information about squares, they are super cool. We already kind of did this problem when we talked about rectangles, but I just want to emphasize that it's the same thing when you're talking about squares. If you want to figure out the measures of each of these angles, you can say that they're all equal to each other by the definition of square or rectangle. And you can say that if you add them all up to 360, that would be the corollary to the polygon interior angles theorem. So you could substitute A in place of B and C and D, combine like terms, and divide to figure out that all four of the angles must be 90 degrees. Or like I said in the rectangles video, you can just memorize the fact that if it's a square or if it's a rectangle, then all four angles must be right angles or measure 90 degrees, because if they all add up to 360 and they're all the same, then they would have to be 90. And since a square is a rhombus, all four sides must be congruent to each other, so F is 9, G is 9, and H is 9 because of the definition of square or the definition of rhombus. So let's see what we have in our next problem, because we have two different variables to solve for. We got a couple of j's and one k. So these j expressions are representing pt and rt. Well, those are the two diagonal segments created by the intersection of SQ and PR, and according to the diagonals of a parallelogram theorem, we know that those two segments must be congruent to each other. So I can say that 7j minus 10 equals 5j plus 6 because the diagonals of a parallelogram bisect each other, so j must be 8. Cool. Well, the other thing that we're supposed to solve for is k. K is representing the length of SQ. SQ is an entire diagonal, and since this is a square, I know that the diagonals are congruent to each other. So if I knew the length of PR, I could set that equal to 9k minus 7. Well, we could figure out the length of PR by plugging in 8 for each of these j's. So 7 times 8 minus 10 plus 5 times 8 plus 6 would give me the entire length of PR, and I can set that equal to 9k minus 7. So solve that all out, and we find out that k must be 11 centimeters because of the diagonals of a rectangle theorem. And that's all you need to know about squares and rhombuses and rectangles and parallelograms. In our next video, we're moving on to something a little bit different, which is trapezoids. Trapezoids are kind of their own category because they're not parallelograms. So for trapezoids, we're kind of starting from scratch.